Hey, it's Alex. This is our game Carnage. I'm recording this video for the second time since I didn't have enough time in the last one. So let's repeat the whole process. So the first thing is first. The first thing you recommended to us, well, actually to myself, in order to add a second character, I just ended up using two player instances. I had a player manager class. I deleted it. It proved to be useless. It didn't work. So it was a manager class, a simple struct to keep track of all the players and their IDs. But I found this implementation to be a little bit easier. Okay, so let's go to world. So in world, so first of all, I just zoomed out the world view a little bit just to see a little bit more. I used your add character code function from the networking code you have posted on Moodle, which is pretty simple. It just creates a character with a local identifier, so all the players and characters have a local identifier set up. On player characters, it pushes back the whatever player you created just there, and then it attaches it to the scene graph. Okay, then we'll texture nope, mutators. So I added things like increment. So I've added a state. It's called the scoreboard state. It just after losing or winning the game, it says game over and then goes to a game over state. I will show this in a playthrough and I'll explain a little bit in depth there. What else? Okay, I'll just continue on for this. So obviously we had to reset the velocity on every character, so I used the unplayer characters array, which just made it quite easy. What else? The draw. Nope. Get mainfold. So this is a function I found online. Bits and bobs I found online. I mostly read through a lot of pages trying to understand how this works. But the idea is so this returns a vector 3f. The reason it's a 3f is because we use the x, y, and z for different things. So the x is the collision, the x-axis normal, then the y-axis normal, and then penetration amount. So I'll explain that in a sec. So you give an overlap, and then you give a collision normal. So the overlap is the overlap of two fluid rects, which is the intersection itself. So if the width is less than the height, you can straight up presume it's x-axis, because that's the way it just works. And then it sets the mainfold x to be, so if it's greater than 0 in the collision normal, then I'll set it to be 1, which is a unit vector, or otherwise. And then mainfold z will be the penetration amount, which is the width. Otherwise, it'll just use the flip side. Straight away, you're still setting the y, and you're checking if the y is greater than 0, set it to a unit vector, and then you use, instead of width, you use height to determine the amount of penetration, because we're y-axis. So we check x, and then we check y. Okay. And then I'll just on that, see more references straight away. Okay, so in our collisions in our game, so we have fully working collisions where you can characters can glide each other. So zombies, characters, players with players, characters or players, boxes, and all that stuff. So this is kind of redundant, but I had to do it because I used the intersects method. So once we determine there is a collision, I check the intersection. And the second argument, which is usually unused in the intersection in SFML, is the out variable to basically it's the intersection between the two collision fluid rects, and then I can use that intersection to determine a normal. So like we use the mainfold. Once again, I get mainfold fluid rect of colliding bodies, and then it returns vector 3f and all that. So you get the mainfold, you use the intersection and the difference between the distances of the players. So using from their center points, of course, and then I assert that a dynamic cast can be made into an entity, and if it can, then obviously we'll do it, and then we'll move the character according to the normal and multiplied by the main fold z, which is the penetration. So basically, if the two colliding bodies, you get the reversed normal that will push you out to the closest nearest edge of the wall, and main fold z is the amount of force you have to, amount of movement you have to apply for you to be outside of the collision. And then this happens with zombies. So if it's character zombie, I have also added a timer, so the zombies will hit you every 600 milliseconds, which is 0.6 of a second, and they'll apply damage to you, and then it'll reset the time. So it's just basically a continuously running timer. Okay. What else? Creation, nope. So where's CPP? No. So player CPP. So how I went about this? I added the local identifiers, and then I've used your structs. I've used one of your structs from your networking code that you have done for the local identifier, and then I just created one for character mover, character fire trigger, grenade starter, and launcher, because the way Michael written his grenade is you first launch the grenade with the same button, and once you release the key, you throw the grenade. So it's the same key overall. Another thing I do is, so if joystick not set and there is an available controller, so we check this. Every player has a joystick. I'll explain this. So it's a class I made. It's an Xbox 360 controller interface. Basically, every player has a pointer to it, and I set it to null pointer at the start usually, and then, as you can see here, so it checks if it's a null pointer and there are connected controllers. We give that joystick, set the joystick to a new instance of it with the current local identifier. Otherwise, if it was disconnected, you can, or if it's disconnected or if there's no available controllers, you just set it back to null pointer. Okay, and this is how I went about just creating initial bindings. So I just check the local identifier if it's 1 or if it's 2. These are default controller bindings because we have the working controllers. So the RB is the shoot, and then X and X is start and launch grenade, which means you start, you press it, or you release it. Okay, so for handle event, one thing I've done is, so these are just, this is the normal handle event for the key pressed for the rocket that you've made. Michael did this for the release of whenever you throw the grenade. But here I check, so first of all I check if there's a controller connected, I check if there was a button pressed, released. It's basically the same thing that this does, but this does it for a controller version. And here I just static cast to a joystick button, which I created a class, an enum. So funny enough, they're in exact order the way the buttons are labeled in SFML. So A is actually 0, so you check is joystick key pressed, joystick index, which can be like 0, 1, usually it's 0 if one controller is connected, if 2, then it would be 0 and 1, and then the key, which is like an enum. You can either write 0, 1, 2, 3, which is, they're all in order, or you could just use this enum, which just made it a little bit more readable, and I just cast it. I get the event, joystick button, and button from it. Also, I do check if the joystick is the ID of the joystick that the button was pressed on relates to the player identifier, or both players will be doing the same actions, which means throwing the grenade at the same time. Alright, so nothing changed here. Apart from mJoystick connected, once again, I check all the pressed buttons, which is actually not too hard. It's just, it does the same thing but for controller. But when it comes to joystick analogs, they're based on axes, and I can't set a specific axis. So for example, axes are always changing from like -100 to 100, so I can't do it in the way you have structured it here. So I just hard-coded it. Well, it's not really hard-coding, but it pushes a command if joystick up was pressed. So if the threshold of the left analog stick on the y-axis is greater than -50, then this command will be called pushed to command Q. Okay, and then obviously set controller, set mission status, not much here. derived actions with using a local identifier, which is great. Makes our life easier. So application is done. Character. Okay. Characters. So draw current. So the player score. I'll just turn on the game. I'll just explain this a little bit. So the screen is the same. Just change the images. In setting states now there's two sets of key bindings you can apply to both, but you cannot set the controller key bindings. So I'm using two controllers right now, which you can see two characters moving. Let's go for collisions. So I collide into a box and I can actually slide against it. If I rotate, it'll just move me up and down. Same with walls, but here I can't really slide. Oh, I can. Okay, never mind, it's fixed. Okay, so let me kill that zombie. Okay. Oh, you just nearly killed my friend there. So you can see we can collide both with my friends, my local player here as well. The zombies don't drop any drops, but boxes do. So we see we got a little bit of health. Now we have a little boost for shots. Yeah, there we go. Also, the second player gets moved when the view gets moved as well, which makes our lives a little bit easier. So yeah, also if I disconnect the controller, I can still use my keyboard, and then once I reconnect, I'm back to using my controller again. If you can hear me actually pressing key. So then once we die, I'll just getting ready to die here. There, I'll just walk up to him. So zombies hit every like 3 seconds. So like obviously he'll kill me now. It says game over. And then we're set to the scoreboard. Scoreboard's pretty simple. I just count it up. So projectiles have IDs, and it determines if the projectile that killed the zombie was with the ID of the whatever player. Their score gets incremented between character CPP, player CPP, and game state CPP, and all this information then gets gathered. So since player is in context, player information, player pointers, we can literally set the score on the player at the end. Points, the point multiplier is 10, so every kill you make is 10. So to get the kills, I just divided the overall points by the multiplier. I didn't bother recording how many kills they made, so maybe I should have done this the opposite way around, where I record how many kills and then multiply it by the multiplier to give the score. Obviously, we're hoping to use this score. One of the networking things is this score is going to create an initiative for players to work together to upgrade items between waves. Obviously, other things would be like player health. Player health should be networked in a way that it should be on the server side. Player score should be on the server side. The projectile damage and projectile is also considered a grenade, so both projectiles and grenades should be recorded on the server side or evaluated on the server side. So apart from explosions, the way you mentioned class, we're just going to record the X and Y position of the explosion and then create an explosion there as an event. Michael has talked about possibly detecting for cheating. So for example, incorrect movement. We can probably interpolate the maximum amount allowed moving unit. So basically, if the player tries to move more than whenever they are available to move in that frame, we'll just either ban them straight away or just rubber band them back. So using score, we'll be able to determine basically to use upgrades. Different colors will be set to every player, so you can visually determine the different players, and everybody's going to be getting a unique ID, just like the local ID here. Everybody's going to receive a unique ID. Before I finish up, I have 30 seconds. For our GitHub, I have implemented a thing called AppFair, which is a great continuous integration tool. So you will be able to look at this yourself, so you can actually press on it. I have it open here. Our current build got built completely fine. We haven't made any tests, so this just checks for a build. Yeah, and then we... Oh, one sec, this moved up. And then we also use Trello to keep track of all the bugs and all the production stuff we have done, which I will link to you in the middle. Thank you very much for your time. Bye-bye.